Next up is from the Population Health Sciences, Maria Caluianu, with Getting a Molecular Train Back on Its Tracks. Good luck.
Take it off.
No, I need it lower. Sorry.
It's not closer.
Yeah. Closer. Yeah. Okay. Wait. Is it on? Okay. Thank you. Sorry. So, imagine you're about to have your first child. You're really excited, but you're also really nervous. So the day comes, and after quite a few hours of labor, your baby's born. You're exhausted, but you're ready to take them home. Imagine at this point realizing that your child is not well. Watching over the next few months as they develop liver, kidney, and bone problems, fail to gain any weight, and then be told by your doctor that your child has a severe, incurable genetic disorder. Imagine then watching them pass away at only 6 months of age. Now, I can see all of you looking at me going, Maria, why'd you have to start with this? It's so depressing. Well, I started with this because this is a disease I study. It's called ARC syndrome, and it's caused by one single typo in a single gene in a child's genetic code. So, how does one single typo do all of this? Well, to understand this, you have to understand that every cell in your body has a system, a bit like train tracks, that gets molecules to where they need to go. This is called the endolysosomal system. So think of it this way. If London is a cell and each one of us is a molecule, yeah? The endolysosomal system is the London tube. So we all have jobs, right? The tube gets us to where we need to go. We do whatever we need to do, and we keep London running. So what this one typo does is it removes a really important bit of the train tracks, so all these different tubes start to derail. Yeah? So it's Monday morning rush hour, and half of us are stuck on the platform waiting for a train that's never going to arrive, and the other half are stuck underground. London grinds to a halt. Now, what does this mean for a cell? Simple. Molecules don't get to where they need to go, so they can't do what they need to do, and the cell stops working. So, because all of the different cells in the body use this system, all from the ones in your liver to the ones in your kidneys and bones, all these different types of cells stop working, which really explains the symptoms of the little boy I described to you earlier, right? And why they were all across his body. Now, what I do is I look particularly at the kidney, and I look at where and when in development these trains start to derail, and I look at the consequences of the crashes. And then later on in my PhD, what I'm going to be doing is I'm going to be using a gene therapy to put back the part of the tracks that's broken, so that cases like the little boys I just described to you are a thing of the past. Thank you very much.